Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we will be looking at an example where we apply our linear regression formulas to an example set of data. So in the previous lesson, we had derived equations for the slope and intercept for a set of data in terms of average values of the x data, the y data, or these products, xy or x squared. And our general algorithm was based on selecting a model, finding the sum of squared errors, minimizing that, and putting that then into a form where we can use matrix techniques to solve a system of linear equations. And what we need to do next is look at an example. So here is a set of data, and it looks like it's kind of linear. And so if we use this and fit a line to it using this algorithm, I need to first take these values of x and these values of y and average those, find products of the x times x, so 0 squared, 0.5 squared, 1 squared, all the way down, and find the average of those squares. Take the products of my x times my y, so 0.5 times 2.1, 1 times 8.3, etc., all the way down, find the average of those. And then use those in the formulas. So I've done this, and here's my original data in the first two columns. The average values are at the bottom in green. Then I did x squared and its average, and xy and its average. Then I simply need to use those formulas. So the slope is the average xy minus the average x's times the average y's, divided by the average of the x squared column minus the average of the x column quantity squared. So I've thrown those numbers in. I end up with 17.2 is my slope. Similarly, I can find the intercept. This time it is the sum of my x squareds times the sum of my y's. I'm going to subtract from that the sum of my x's times the sum of my xy's and divide by the same denominator as before, and we get an intercept of negative 13.64. So this concludes this example. In our next lesson, we're going to talk about different ways that we can define the error. Thank you very much for your time.